While an oil and gas exploration and production company makes money by selling the hydrocarbons it finds and produces, the company's future viability and thus market value as a business also depends on the company's reserves of oil and gas still in the ground. Like a high-worth individual with lots of money in the bank, an oil and gas company with large reserves still to be produced is generally considered to be a high-worth enterprise. However, the precise amount of reserves a company controls is actually unknown. It ranges between amounts that are very likely and very unlikely. Furthermore, a company's reserves are actually just the economically producible fraction of the total amount of oil and/or gas that may exist under the company's leases. This greater volume of oil and/or gas is referred to as the total resource potential, or the in-place resource. A good way to think about reserves versus resources is in terms of inverse cumulative distributions. That's just a fancy name for plots in which the amounts of oil and/or gas increase along the x-axis, while the probability of exceeding an amount ranges between 0% and 100% along the y-axis. The inverse cumulative distribution for in-place resources follows a backwards S-shaped curve. The point at the uppermost left side of the curve is the amount of oil and/or gas that expert geologists and petroleum engineers contracted by the company agree is almost certainly in place beneath the company's leases. The point at the lowermost right side of the curve, on the other hand, is the largest and least feasible amount of oil and/or gas estimated to be in place. Between these 2 points, the curve descends across increasing amounts of oil and/or gas that are ever more unlikely to exist beneath the leases. Note that the in-place resource curve does not distinguish oil and/or gas that can actually be gotten out of the ground using existing technology from oil and gas that cannot currently be extracted. If we restrict our analysis to only that oil and gas that is currently recoverable, regardless of the cost of extraction, then we produce a second inverse cumulative distribution of technically recoverable resources, and this curve lies to the left of the in-place resource curve. Going a step further and focusing on only those resources that can be produced at a profit with existing technology results in a third inverse cumulative distribution that lies even farther to the left in the plot. This last curve reflects economically recoverable reserves. When you look at this last, most conservative curve, keep in mind that the economically recoverable reserves are not all equal. As before, reserves beneath the left side of this curve have a greater probability of existing than those beneath the right side of the economically recoverable reserve curve. In fact, the economically recoverable reserve curve is often broken into 3 segments. Economically recoverable reserves that have less than 50% probability of existing are referred to as proved, probable, and possible reserves, or 3P reserves. Economically recoverable reserves that have a 50 to almost 90% probability of existing are referred to as proved and probable, or 2P reserves. And economically recoverable reserves that have a 90% or greater probability of existing are simply proved, or 1P reserves. This last category, proved reserves, are further subdivided into developed and undeveloped reserves. Proved developed reserves are those that can be produced from existing wells with up to moderate additional investment. Proved undeveloped reserves are those that can only be brought online by drilling new development wells. In order to be listed on a U.S. stock exchange, an oil and gas company with reserves must report to investors the amount of 1P, or proven reserves, which is the most conservative estimate of their holdings. Reserves reported by companies that are not listed on a U.S. stock exchange are not subject to this restriction, so their reserves may include probable and possible reserves, or even resource estimates rather than just reserve estimates. It is also important to keep in mind that economically and technically recoverable resources can change from one year to the next depending on the cost of using available extraction technologies and the prices that oil and gas are selling for. For example, the cost of fracking and horizontal drilling has declined since the 1990s, changing formerly technically recoverable oil and gas reserves in shales into economically recoverable reserves. So companies with mineral rights to shale oil and shale gas have had their economically recoverable reserve curve shift to the right, increasing both the amount and total value of these companies' reserves.